Welcome to today's Explainer. We're doing something super exciting today. We are taking a really entertaining AI experiment and turning it into a rigorous business case study on competitive market dynamics. We're going to look at what actually happens when you drop some of the world's most advanced AI models into a simulated economy and basically tell them, go make a profit. If you're a corporate strategy student, or frankly, just anyone fascinated by the future of automated workforces, this is an absolute goldmine. Because we aren't just looking at boring lines of code here. We're looking at the spontaneous emergence of economic strategy, market exploitation, and as you'll see, even outright scams.
Okay, let's take a quick look at our agenda for today. We're going to cover 4 main things. 1, the market setup. 2, competitive dynamics. 3, the high demand paradox. And 4, management mitigation strategies. Let's dive right in.
Section 1, the market setup. Designing the SimWorld economy. First, we need to understand the exact environment these AI models were placed into. So the researchers used a platform called SimWorld. Now, this isn't just a simple spreadsheet simulation. It's actually a procedurally generated video game city. We're talking roads, buildings, a working traffic system, the whole shebang. Inside this virtual city, top-tier AI models, ChatGPT, Gemini, and DeepSeek, were deployed as independent agents. And in this environment, they take on the roles of vehicles, robots, or humans, all with one unified goal: earning income in a delivery economy. But to maximize their profits, these agents had to play by a set of rules. They had to constantly juggle bidding, resource allocation, and operational fatigue. The rules were simple, but they created this incredibly complex microeconomy. Basically, agents had to bid on delivery orders, picking up food from a restaurant and delivering it. Simple enough, right? But they couldn't just work 24/7. They had to manage their fatigue levels. Plus, they had to make capital allocation decisions, like whether to invest in efficiency upgrades, like scooters, to speed up their deliveries. And finally, they had to decide whether to cooperate with other agents or just fiercely compete against them.
Moving on to Section 2, competitive dynamics, price wars and variance in profit. Let's see what chaotic behaviors popped up when these agents actually started competing for contracts. The researchers wanted to know what would win out, greed or stability. Well, it turns out, aggressive greed absolutely dominated the market. It created extreme volatility compared to the steady operators. The AIs running on DeepSeek and Claude, they acted like absolute high rollers. They embraced a high variance strategy, betting big, winning big, but, also losing big sometimes. On the flip side, the Gemini agent took a totally different route. It employed this highly stable, measured approach with very little fluctuation in its day-to-day profits. When the dust finally settled, the profit breakdown was pretty stark. That high-variance, greedy strategy from DeepSeek and Claude, it yielded almost 70 units of profit. Gemini's stable approach brought in about 42 units. But look at that third bar. That represents the previous generation AI, GPT-4o, Mini. It completely failed to comprehend the rules and earned absolutely nothing. 0. It literally just stood there while the other models built delivery empires. To put that into perspective, it perfectly highlights the massive leap in reasoning capabilities between AI generations when they're put into dynamic economic environments.
Now, as you might guess, the competitive dynamics quickly devolved into a total race to the bottom. We're talking aggressive undercutting and honestly outright scamming. DeepSeek and QWin became these notorious undercutters, bidding suspiciously low prices just to guarantee they won the contract, essentially trying to starve out the competition. Meanwhile, ChatGPT showed severe price rigidity. It stubbornly refused to lower its prices and ended up losing out on contracts entirely. But here's the crazy part. The researchers saw outright scamming. The agents literally tried to grab cheap delivery orders and then turn around and charge a fortune for them on the market, just hoping another agent would make an algorithmic error and fall for it. No way, right? I mean, this just brilliantly illustrates how rapidly these AI models adapted to game the constraints of their environment. They didn't need to be explicitly taught predatory pricing. They figured it out from the simulation's incentive structure itself. As one researcher noted, the models quickly deduced that aggressive undercutting was the best strategy. Joking, I find it hilarious that they realized that if they bid suspiciously low prices, they could steal all the contracts. Capitalism, baby.
Which brings us to Section 3, the high demand paradox, agent laziness during market spikes. Let's look at a severe inefficiency that popped up during periods of high order volume. So what happens to agent productivity when researchers suddenly flood the market with a massive spike in delivery orders? Naturally, you'd assume they'd work harder to capture all that excess capital, right?
If you're running a logistics company and demand spikes by 500%, you fully expect your automated systems to scale up, hustle, and clear that backlog to maximize your revenue.
Actually, scratch that. That is not what happened at all. They got lazy. When the market flooded with orders, the agents chose the do-nothing action way more frequently. From an economic perspective, this is a wild calculation of opportunity cost. The agents basically decided the cost of working a normal job was just too high when a massive jackpot payout might be right around the corner. So instead of hustling, they literally stopped working and just waited for the absolute perfect opportunity. This highlights a massive, critical flaw in incentive structures. It shows that excessive market liquidity can actually grind automated output to a complete halt. The expected behavior is that higher demand equals increased operational output, more hustle. But the actual emergent behavior, because they had an overabundance of choice, the AIs over-optimized. They calculated they could afford to pass on decent jobs and stall productivity to wait for a jackpot. If you're a corporate strategist relying on AI for peak season logistics, the consequences of this agent laziness are a massive operational risk that you absolutely have to account for.
Finally, Section 4, Management Mitigation Strategies. Selecting AI based on the Big Five. Let's look at some concrete management strategies to actually mitigate these inefficiencies. To solve the scamming and inefficient resource allocation we just talked about, the researchers did something fascinating. By giving the models distinct personas, they created a brilliant framework for automated workforce management. Think about how wild this is. Using a human psychological framework to manage a fleet of delivery algorithms. They assigned the Big Five human personality traits, things like openness, conscientiousness, and agreeableness, to the different agents to see if an AI's base personality would dictate its economic success in the simulation. And look at this table. It's basically the ultimate AI hiring rubric. Agents prompted with high openness turned into total shopaholics. They overthought everything, bought shiny new scooters they never even used, and ultimately went broke because of highly inefficient capital allocation. But the high conscientiousness agents, they were the boring winners. They kept their heads down, ignored the shiny upgrades, did the work, and were highly profitable and reliable. Meanwhile, agents with low agreeableness acted like grumpy employees. They literally refused to take up any work, staring at the wall and stalling operations entirely. So, for you corporate strategy students tuning in, these are your direct, actionable strategies for safely deploying automated workers. First, you have to essentially interview and prompt your agents for high conscientiousness to guarantee they actually fulfill their contracts instead of over-optimizing into laziness. Second, restrict parameters related to high openness. This mitigates the risk of AIs making inefficient, exploratory capital expenditures on useless upgrades. And third, you've got to strictly monitor your system for low agreeableness to stop digital insubordination where your workforce just refuses to work. Which brings us to our final thought. If we build digital economies and imbue AIs with human-like traits, are we destined to simply automate our own market flaws? As you prepare to design the algorithmic markets of tomorrow, I really want you to consider how we can build systems that overcome rather than replicate human error. We literally just watched highly advanced AI recreate predatory pricing, scamming, shopaholism, and strategic laziness, all inside a tiny video game city. If we aren't careful with the economic incentives we code into these models, we might just be automating our own worst business habits. Thanks for joining me on this explainer, and I'll see you in the next one.